This is Keith Albertson of IISC. We're here at the Applied Ergonomics Conference in Orlando with another podcast break. And one of our keynote speakers, please introduce yourself.
Hi, I'm Nancy Currie-Gregg. I'm a professor of engineering practice at Texas A&M University. And I'm a PhD in industrial engineering with a specialty in ergonomics and physical factors.
And you're also a former astronaut who flew space shuttle missions. You were part of the space program for many years. Your talk was very much centered around that and the need to be able to tailor whatever a workplace has toward its workers. You talked about the need for spacesuits and accommodation for astronauts of different diversity and stature. Tell us a little bit about your journey into ergonomics from the space program.
Yeah, that's a great question. So maybe you can't tell on video, but I'm a little bit vertically challenged. I do hold the distinction of smallest astronaut ever, shortest astronaut ever. I think I'll hold that title. They have recently changed the stature requirement to 62 inches, just in this latest selection in 2021. And so my career, I was very fortunate. Things changed at just the right time. When I was just a few months from graduating at Ohio State University, they changed from a 5'4" stature requirement for all the military services for pilots to anthropometric measurements. Quite frankly, that's the first time I heard the term anthropometry. And what it is a recognition that, stature has very little to do with operating an aircraft or spacecraft. And what really matters is, do you have the functional arm reach? Do you have the right seated eye height to look outside the aircraft as well as to see all the critical instrumentation and gauges inside the aircraft? And then finally, leg length, particularly for operating a helicopter with anti-torque pedals. And so in recognition of that, they said, stature really has nothing to do with it. We're going to switch to anthropometric measurements. And so that answers the question, why did I pick the Army of all the services? Because I wanted to be a pilot. A, I wanted to fly helicopters. And B, I was too short for all the other services. The same thing, around the same time, I graduated in 1980 from Ohio State. 1978, they picked the first female astronauts ever for the shuttle program. And in recognition of that, they had to change the anthropometric requirements for the astronaut corps. Now, at that time, they accommodated 5th percentile American female and 95th percentile American male. But then when we started partnering with the Japanese and the Canadians, Europeans, the Russians, they expanded that envelope to include 5th percentile Asian females, at which point I easily made the criteria. But quite frankly, even though the selection criteria changed over time, the design of the equipment that astronauts interfaced with didn't change. And most of that equipment was built for the military. They were built on military specifications. And so if you look at legacy equipment that was built and designed in the 1970s, maybe even early 1980s, that was primarily based on military male anthropometry. And as we know, females are not just little scale versions of their male counterparts, right? They have very different anthropometry and very different requirements. And the design of equipment where maybe brute force will work for a male, maybe if the design was changed such that, it can now be finessed into that state. And I use that example because I flew an aircraft and I was an instructor pilot that I had to control with the hydraulics off. And quite frankly, I had quite a few people come fly with me because they were skeptical. Could I control this aircraft with the hydraulics off? Because the male pilots were just brute forcing the controls with the hydraulics off. But I learned to finesse the aircraft down and to apply less force by, if I just put a little bit of pitch in, then that would reduce the force required to lower the collective and to start a descent. And so I learned workarounds, if you will, where I didn't have to brute force things. But there are some times where some piece of equipment just fits so poorly that it actually inhibits functionality, productivity, and perhaps can impact the safety.
And you really connected the dots between space travel and ergonomics maybe in a way people don't realize, because certainly the job of an ergonomist is to design the workplace and the work and the specifications to the worker. It's no more important than in space, right, where you don't have the option of redoing things on the fly. It has to be, human safety has to be a high priority at any time when it comes to space travel.
That is so true. And I think the ultimate irony is I thought about this talk, and I've never given a talk about this before because I didn't want it to be construed as anything negative against NASA. And that's not the intent of that. The intent is to let the community know that these problems even exist beyond our planet. And what I found was quite ironic is I spent thousands of hours in simulators, learning how to control situations, learning how to reconfigure aircraft and spacecraft in an emergency situation. And yet, there are certain circumstances that I could get in. For example, if we were ever to become depressurized, where because the pressurized suit does not fit me well, despite the fact that I have all the knowledge and skills that I need to perform that role, my performance might be impeded because of the poor fit in the safety equipment. And I find that ultimately ironic because I prided myself on knowing everything I could about every system that I ever flew, whether it be a helicopter, an airplane, a jet, or a spacecraft. And I was always known as kind of, the system specialist. I knew everything about the system. And I did that so that I could control the situation and hopefully have a good outcome when we had off-nominal or emergency situations. But if my functionality is impeded because the systems I'm interfacing with aren't really designed for me, then really that's a disservice not only to me, but my fellow crewmates as well.
And how do you feel the Artemis program certainly is the one that is coming up very soon, return to the moon and then later to Mars. And some of these issues have been in the news concerning the Artemis program, the design of the suits. How do you feel about the return into space and maybe this now becoming something that is going to be a higher priority going forward?
Yeah, I think, first of all, I am super excited about the Artemis program. For one, when I was selected as an astronaut in 1990, then President Bush said, we're going back to the moon and on to Mars. And so our class patch, our astronaut class patch from 90 had the moon and Mars on it. And we thought, wow, this is great, we're the ones. And of course we weren't. And so we've kind of gone in fits and starts. We're going back to the moon, we're going on to Mars. And now we can see it, right? The vehicle sitting at the pad, ready to go do a test flight, the Artemis 1 flight. And I couldn't be more excited because we're destined to explore. It's embedded in our nature to explore beyond our boundaries and to explore beyond the confines of where we've been for decades now in low Earth orbit and go back to the moon and ultimately onto Mars and truly start to explore the universe is super exciting.
It very much is, yeah. Tell us just a little bit about the kind of research and the work you're doing right now at Texas A&M and in your role that you have there now.
So I have two roles. I'm a faculty member, and as part of my research as a faculty member, my research area is spacecraft occupant protection. And so we use highly biofidelic models of a human. We used to use anthropomorphic test dummies, like hybrid 3s, like you use in car crash testing. And then we use computational models of those dummies. And we would expose them to the forces that you might be exposed to, like during a landing sequence. All the next generation spacecraft are all capsules. They all come in under parachutes. They land to land or land to water. Some have airbags, some have retro rockets. Some just have the parachutes and the seat stroking mechanism to reduce the forces transmitted to the humans. But lately we've been using something called the GHBMC, which is the Global Human Body Model Consortium. And it is a very biofidelic model. So now we're not testing and doing finite element models of dummies, but we're using a body model that was based primarily on cadaveric testing So it responds much more like a human than a metallic dummy does. So we're looking at that particularly with respect to small females, right? Neck injuries, head injuries, lower lumbar injuries, as you're exposed to these forces of rapid acceleration pulses during the landing sequence. And takeoffs are optional, landings are not. So landings are going to happen. And all landings in a capsule are a dynamic event. I mean, coming in on the shuttle is like coming in on United Airlines, right? Came in very benignly, touched down on a runway, rolled out. When you come in a capsule, you definitely know you've landed. And those forces are being transmitted to the human body. So it's how do we reduce that? Because we can't be injuring people on what is a nominal event. Landing is nominal. If I told you every time you pulled your car into the garage you were going to crash, right, and might be injured, that would not be acceptable. And then in my other role, I'm the Chief Technology Officer at the Bush Combat Development Complex. And we're doing really exciting applied research for defense-related issues. And we specialize in integrated hypersonics, so rapid design of hypersonic vehicles. And we look at integrated network autonomous vehicles, so vehicles that will go out and do things so that we don't have to expose humans to undue harm. So, whether it's going out and searching for mines, whether it's going out to acquire intelligence, by using autonomous ground and air vehicles, we can expose the humans to less of a risk and only expose them when it's absolutely needed. And I'll tell you, part of our philosophy at the Bush Combat Development Complex is called Agile Technology Development, which is, our motto is fail early, fail fast. And what it is it's discover the problems early, including problems with, do our systems properly accommodate human operators, right? Not just physically, but cognitively as well. So, you've got all the sensor data coming in, and I always would joke with our engineers at NASA and told them that you just look at me as a human fusion sensor device, right? So I'm just taking all these pieces of information. But as we know, we can cognitively overload people when we do that, and thereby negatively affect their performance. So we're looking at all aspects. And the sooner you get things out, so we have 134 acres of a fully instrumented test grounds where we can take these full-scale autonomous vehicles out, put them through its paces, in the dark, down a cliff, up the side of a hill, right? And see how they do in a really relevant environment. So that's really important for researchers to get out of the lab, get into the operational environment where people are actually going to use this equipment in the environment they're going to use it, and then see if that equipment is designed properly.
Well, you definitely had a group of interested ergonomists in there who see all of these lessons and how it applies to what they do and what they can take back. We very much appreciate you being at our conference. We hope you'll join us again in the future and stay in touch with our Ergonomics Society, and we very much appreciate you being on our podcast.
Oh, thank you. Thank you very much. It's been an honor.